This is a video from section 1.3 in a linear algebra class. Let u equal the vector u1, u2, u3 all the way through until un. Let v equal the vector v1, v2, v3 through vn. The dot product of u and v is equal to u1 v1 plus u2 v2 plus u3 v3 plus all the way through until u sub n v sub n. For example, suppose I let u equal the vector 3, 2, negative 4. And by the way, this is how they write vectors in linear algebra. If you are taking a Calculus 3 course, most likely they're going to write the vector in this format. So 3, 2, negative 4. So it's going to look more like this, okay? Now, suppose u is the vector 3, 2, negative 4, and v is the vector 4, 5, 6. The dot product of u and v is equal to 3 times 4. So notice I take the first component of u and multiply it by the first component of v. Then I'm going to go plus 2 times 5. So I take the second component of u times the second component of v. And then I go plus negative 4 times 6. So I take the third component of u times the third component of v. And we multiply. And then add up those results. So I get 12 plus 10 minus 24, which is equal to negative 2. Now, when we talk about multiplying matrices, we can think of a row as like as a vector, right? So in other words, we're going to take the row of the first matrix and the column of the second matrix, and essentially you're performing a dot product. And that's how I like to think of matrix multiplication. I will explain this further as we go along. Now, let's talk about matrix multiplication. If A is an M by R matrix and B is an R by N matrix, then A times B is an M by N matrix. Notice, the number of columns of A, the first matrix, must match the number of rows of B, and B is the second matrix, in order to form the product A times B. So notice how the R's match, right? So in other words, the columns of A match the rows of B. The size of A times B is determined by the rows of the first matrix and the columns of the second matrix. So in other words, the dimension or size of AB is M by N. Okay? And with that, let's take a look at some examples. Suppose A is the matrix 3, 0, negative 1, 2, 1, 1. B is the matrix 4, negative 1, 0, 2. C is the matrix 1, 4, 2, 3, 1, 5. D is the matrix 1, 5, 2, negative 1, 0, 1, 3, 2, 4. And E is the matrix 6, 1, 3, negative 1, 1, 2, 4, 1, 3. We want to find the following. In part A, we want to find AB. In part B, we want to find BA if it is possible. In C, we want to take the quantity 3E and multiply it by D. In part D, we want to take the quantity A times B and multiply it by C. And then in part E, we want to take A times the quantity B times C. And let's get started. Now, I'm going to take A times B and figure out what this matrix is. Now, I want you to notice something. A is a 3 by 2 matrix, 3 rows, 2 columns. B is a 2 by 2 matrix. Notice how the columns of A match the rows of B. So we can talk about the product AB. The size of A times B is going to be determined by the rows of A along with the columns of B. And if you notice, the size of A times B is 3 by 2. Okay, now, we're going to determine the entries of A times B. And I go through it all, okay? Now, let's take a look at the entry in the first row, first column. So this is how I like to think about it. Essentially, I'm going to take the row, first row, and I'm going to dot it with the first column, right? So in other words, I'm going to take the first row of A and dot it with the first column of B. And that's exactly what I'm doing here. So I'll call the first entry C sub 1, 1. C sub 1, 1 is equal to 3 times 4 plus 0 times 0. Think about it like a dot product. And then the answer is 12. Now I want the entry in the first row, second column of AB. And I'll call that C1, 2. Now, the second column is located over here. And so to find C1, 2, I'm going to take 3 times negative 1 and add 0 times 2. And I get negative 3. To find C21, I take the second row of A, and I'm going to dot it with the first column of B, essentially. And when I do that, I get negative 1 times 4 plus 2 times 0, and the correct answer here is negative 4. And that's, again, right there. If I want the entry in the second row, second column, I'll call that entry C22. That's negative 1 times negative 1 plus 2 times 2. You get 5. And then C31, the third row of A is right here. And I'm going to take the third row of A and dot it with the first column of B. And when I do, I get 1 times 4 plus 1 times 0, which is equal to 4. And then if I want C32, that's right here, I get 1 times negative 1 plus 1 times 2. And that's equal to 1. So after all that, we found the product AB. BA. Now notice, B is a 2 by 2 matrix. A is a 3 by 2 matrix. The columns of the first matrix, B, do not match the rows of the second matrix, A. And so therefore BA is undefined. We cannot do BA. So that tells me matrix multiplication in general is not commutative. It's not going to happen. So part C, I'm going to take the quantity 3e times d. But this is 3 times the matrix 6, 1, 3, negative 1, 1, 2, 4, 1, 3 times the matrix 1, 5, 2, negative 1, 0, 1, 3, 2, 4. Okay, now when I do 3e, that means essentially I'm going to take every entry of E and triple it. And so over here, we get the matrix 18, 3, 9, negative 3, 3, 6, 12, 3, 9, times the matrix 1, 5, 2, negative 1, 0, 1, 3, 2, 4. And so if you notice, I go through and find every entry of that product. And I start with C11. C11 is equal to, now look, I'm taking the first row of 3e, and basically dotting it with the first column of D. And that's where I'm getting 18 times 1 plus 3 times negative 1 plus 9 times 3. That's 42. And then I'm going to find C12. So it's the entry in the first row, second column. And that's 18 times 5 plus 3 times 0 plus 9 times 2. And that's 108. C13 is 18 times 2 plus 3 times 1 plus 9 times 4. And I got 75. C21, so I'm looking at the second row here, dotted with the first column over here. And that's negative 3 times 1 plus 3 times negative 1 plus 6 times 3. I get 12. C22 is negative 3 times 5 plus 3 times 0 plus 6 times 2. That's negative 3. And we're almost done. C23. So I'm looking at the second row of 3E and the third column of D. And that's where I'm getting negative 3 times 2 plus 3 times 1 plus 6 times 4. 21. C31, I come up with 36. C32, I get 78. And C33, I get 63. And I'm just doing dot products the whole time. So if I take the quantity 3E and multiply it by D, I get the matrix 42, 108, 75, 12, negative 3, 21, 36, 78, 63. Part D. Suppose I want to take the matrix AB and multiply it by C. Don't reinvent the wheel. We already figured out what A times B is. A times B is 12, negative 3, negative 4, 5, 4, 1. And I'm going to multiply by matrix C. Matrix C is 1, 4, 2, 3, 1, 5. And when I multiply those matrices, I come up with the following. I get the matrix 3, 45, 9, 11, negative 11, 17, 7, 17, 13. And so again, it's a dot product. Notice how this entry is in the third row, first column, right? So if I take 4 times 1, right? So in other words, I'm taking the first row of AB and dotting it with the first column of C. So I take 4 times 1 plus 1 times 3, and I get 7. That's literally how this works. Okay? And then on part E, now, by the way, my goal in part E is to figure out A times the quantity BC. But to do that, we need to figure out what BC is first. BC is the matrix 4, negative 1, 0, 2, times the matrix 1, 4, 2, 3, 1, 5. And I get 1, 15, 3, 6, 2, 10. So that's the matrix I'm coming up with. That's BC. So A times the quantity BC is the matrix 3, 0, negative 1, 2, 1, 1 times the matrix 1, 15, 3, 6, 2, 10. And when I multiply these two matrices, I get 3, 45, 9, the matrix 3, 45, 9, 11, negative 11, 17, 7, 17, 13. And I want you to notice AB times C is the same thing. I get exactly the same matrix. And it turns out that A times BC is the same as the quantity AB multiplied by C. Okay, that'll do it for this video. This is a video on section 1.3, and we talked about multiplying matrices. Thank you.